Hello, Python Padawans. This is our second set of material over software and assignments. So let's just go ahead and get right to it. In this topic, we're going to be talking about how we use software and how software can be an important tool in developing our problem solving that we do with computer programming. We're going to discuss the idle programming environment, and that's the software we use, the tool we use to actually create Python programs. We'll talk about Python program structures and explore the development process for how programs actually get created. So Python programming, the environment itself, the idle programming environment itself comes in two parts. There's an interactive prompt that you use to just test short snippets or commands. It's a quick way to see what commands will work correctly. So when you're trying to write your programs, if you're not sure of the syntax of a function or a command, you can try it out. But this is not where we write full programs. It's the interactive prompt. The editor is where we write full programs. You always know you're in the editor because it doesn't have the 3 greater than symbols that you see in the interactive prompt. Instead, you'll see that it's got color-coded feedback on each component. So when you type in the commands in the editor, it's very much like a word processor. Each of those commands gets color-coded, a different color for a function versus a string versus variables and other statements and elements. When you write your programs in an editor, as I said, it's very much like a word processor. So you write your programs, you write your statements out, then you save your file, and then you execute it. Almost all of your work this semester for CS 177 will be done in the editor window. And your very first assignment, Lab 1.1 and also Lab X, Programming Exercise 1.1, you'll be using the idle editor to create programs. And in Lab 1.1, you'll also do some work at the interactive prompt and save and submit that work as well. So you get an experience for the 2 different tools, the 2 parts that make up idle, our programming environment for Python. When we're in the editor window, as I said, things are color-coded. So comments, we call it pseudocode. These are statements that are not executed by the computer. Instead, they're just human readable. They're for us. Those are always in red, where basic statements like assigning 6 to the variable y, that sort of thing, those are in black. Built-in functions and commands like for and in, those are orange. And purple is reserved for built-in functions like the print function. You also notice that there's a little string in this example, and it's in green. It's inside quotes. So whenever something's within quotes, it'll automatically be labeled in green. The interactive prompt works a little differently. While you may see some color coding, you'll know you're at the interactive prompt because the window title up here will say Python shell. And you get these 3 greater than symbols, which indicate a prompt ready for you to type something in. And if you type things in, they happen immediately. So if you'll say X is assigned to value 5, for this example here, we're assigning 5 into the variable X, and we say print X, it shows 5. We can type in statements like 7 plus 8 plus 10, and it'll respond immediately with 25. It evaluates it. When you execute your programs from the editor, you run them, it'll give you this restart prompt that just tells you that you've just rerun your program that you've saved in the editor. And if you've run a program and that program does something, you'll see the output of that program here at the Python shell, the interactive prompt as well. So this is the output of a program that prints values from 0 to 25 by 5s. So that's just a couple of examples of the differences between the idle editor and the shell. So the software development process is something that you're going to go through repeatedly this semester. And the software development process includes several components. The first is, it's how we break down our programs so that they, into stages, so that we can decide which information is going to be produced for each phase. So we think about the steps. You've probably done this in high school or junior high where someone said, write down the process to create a peanut butter and jelly sandwich or to create a glass of chocolate milk. And your steps are get a glass, get milk, pour milk in the glass, add chocolate to the glass. Those steps are the stages, with each of those stages having a different intention or a different purpose. And when you put them all together, what you have at the end is, well, in this case, chocolate milk. Or if you got the bread and you got the peanut butter, maybe some jelly, you add them together, you make a peanut butter sandwich. You need to be a lot more detailed than that, of course, when we write computer programs, but those are just a couple of examples of those stages. The first element in developing software is to analyze the problem. You have to figure out exactly what you're trying to solve. You need to understand as much about it as possible. If there's anything complicated, if there's some element in there that you don't know how to do, you need to analyze it. In all your assignments this semester, what's going to happen is we're going to present you with problems. Early in the semester, we're going to break them down for you, kind of give you a hint as to what exact problem must be solved. As we get further into the semester, that's something you have to do. Analyze the problem, break it down as much as possible, and try to understand what needs to happen. The second step is to determine the specifications. What will your program do? If we give you an example of output of a program, you're supposed to write a program that counts from 0 to 25 by fives. Then you need to make sure you know what that would look like. So we might give you an example of the output, much like the example on one of the previous slides. You don't worry about how it's going to do it. You just try to figure out what it's going to do. And this would also include describing the inputs. So is the program going to count from 0 to 25, or is it going to count from X to Y? Maybe even in increments of Z, right? So if I'm counting from 0 to 25 by fives, I'll say I'm going to count from X, let's say 0 to Y, 25, by increments of Z, 5. And then the user can actually change those values potentially, right? So you want to think about the inputs, think about the outputs, and how they're interconnected with each other. And that's the second part of the software development process. The third part is to create a design. What does my program do, and in what order? What does it need? And a design includes the overall structure of a program and how it actually works out the solution. You do get to choose and develop your own algorithm, and that's the important thing, is that there is no one way to write a program. What you might think is that, you know, in a class like CS 177 or any other programming class, we ask you to solve a problem. We're asking everyone in the class, which is hundreds of people, to solve the same problem. So there must just be one solution. The reality is there's not. There's an infinite number of solutions, different approaches to solving the problem. It's the same, and I've used this example many, many times in the past. It's the same as if I was an art teacher and I asked two students to sit in separate rooms and draw a picture of a cat. Now, we all know what that cat should look like, and we can look at each of those two pictures and say to ourselves, that's a cat. But will those pictures be the same? No, they won't. In fact, there's no chance that those two pictures will be the same, zero. They might have used a similar approach, and yet their outputs will be different. Will they both be cats? Yes. But will they be the same cat? No. So you develop your own algorithm, your own way to draw a cat, as long as it meets the specifications of the assignment of the program. The next thing to do is to implement the design. This is where we convert your approach to solving the problem into the actual Python language, in this case, Python. All right, and finally, once you've created the program, you've got a design, you know how you're going to implement it, you've started writing the Python code, then you need to test and debug it. This must be done over and over and over. You're going to test and debug your programs many, many times. And in fact, you're not just going to run your program to see if it works correctly or to fix any bugs or problems. They call this debugging. You're also going to try to find errors. So try everything you can think of that might break your program. My example a minute ago, you're going to write a program that that displays numbers from X to Y in increments of Z. The first example was from 0 to 25 in increments of 5. But if you're going to ask the user for the starting value, the ending value, and the increment, try running your program and typing in 0, 25 by Bob as the increment, right? What happens to your program? Does it crash if you don't give it a number? What if you gave it numbers with decimal places? Does it crash then? So you want to run your program and see that you can get it to work regardless of the inputs of the user. And maybe the user typing in certain values needs to be prompted. These are supposed to be integers between 0 and 100, or whatever numbers that your program specifications clarify need to be used. So let's say I want to write a program that displays all positive integers from 1 to 10. So I'm going to start by writing down the steps, and I'm going to begin each step with call it a hashtag, a pound sign. It's a comment character in Python. We start with the comment characters, and we block or organize the logical process within our program. So we're going to count from 1 to 10. So let's start by setting a variable of some sort to 1, right? So we'll pick a variable n. We'll set n to 1, and then we're going to repeat 10 times. Print n, and then increase by 1. So we're going to do this 10 times, right? So if I print n the first time, right, in my loop of repeating 10 times, I print n the first time, it's 1. I increment it by 1. Now I'm going to go my second loop, right? As I get to the end, eventually n is 11, but I didn't print it as 11, right? I stopped printing after n was 10. So if this is my process, this is not the Python code. These are just the logical steps in my program. N is 1, and 10 times I'm going to print n and then increase it by 1. This would be the output of my program. And if my program is supposed to display the positive integers from 1 to 10, then my program structure actually accomplishes that task. So let's check this. Let's see how this works. Let's say I'm going to accept 2 values from the user that represent the length of 2 sides of a right triangle, and then calculate the length of the hypotenuse. Well, Pythagorean's theorem says in a right triangle, there's a calculation for that. I don't need to know the calculation. I don't need to know the formula. In fact, the only thing I need to know is accept 2 values from the user and calculate the length of the hypotenuse. I don't need to put the formula in my plan. I can go look the formula up, right? But as long as I have a plan, so here's my plan: accept 2 values from the user, calculate the hypotenuse. That's it. That's it. Just the logical process of writing this pseudocode, this natural language, human readable language pseudocode to solve the problem would just be these 2 steps. Let's try another one. I'm going to accept the radius of a sphere from the user and then calculate the diameter, the volume, and the surface area. I don't know those formulas, but I don't need to know them to have a plan. Let's say I know some of them, right? So first I accept the radius from the user, and I'll calculate the diameter of the user. I happen to know what that formula is. It's 2 times the radius, but that's fine. And then I'm going to calculate the volume. Don't know that formula off the top of my head, but I can look it up, right? I'm sure it's available somewhere. And then I'll calculate the surface area. I'm skipping the steps where I display them, but my program specifications didn't say display those values. It said calculate those values. So you don't want to add things to your program that aren't in the specifications. If the specifications say, accept the radius of a sphere from the user, calculate the diameter, the volume, and the surface area, then that's all your program should do. And in my example here, I've got the pseudocode to do those 4 things: accept the radius, pound sign or comment sign, calculate the diameter, calculate the volume, calculate the surface area. So as we go forward and you're writing your programs or using the idle tool to write your programs, keep this in mind, that you always start by planning out your logical process. As you're working through the first homeworks this week on CodeLab, after you set up your CodeLab account, if you're not sure what CodeLab is, go back to that Getting Started module that's in Brightspace. That'll remind you that you need to set up that CodeLab account, okay? When you're solving those problems in CodeLab, don't start by writing Python code. Start by writing pseudocode. Plan it out. What you would do here, if this was what that program asked you to do, is you would add a blank line between each of these statements and then put the Python code in between them to solve the problem. But these pseudocode plan is what's going to be the most powerful tool for you as you move forward and learn how to solve problems in Python. All right, so once again, writing programs. We follow these general steps. First, block or plan out your code using pseudocode comments. Then determine all the formulas and algorithms you need. If you don't remember the formula for calculating the volume of a sphere, you can go look it up. Then after each comment, insert the Python command right after the comment that completes the step, and then test, 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 right? So you've got your specifications, you block or plan out your code, go figure out the parts you're not sure how to solve, and then after each comment, insert the Python commands to complete it, test it regularly, and make sure that you know what your program's doing. All right, so that's it for this module. There's a quiz that follows it on Brightspace, so go ahead and go answer the questions on that quiz.